Hello there, welcome back. Today we're going to talk about integration by parts. So that's basically when you have two functions that are multiplied with each other and they're different, and you have to integrate them. So it would look something like this. So you have integral f of x times g, let me g of x, there we go, dx. So that's what it would look like. And the way you do that would be using this formula. And the way I remember this formula is you have the first function times the integral of second function minus the integral of the derivative of the first function times the integral of the second function dx. So let me just put that thing in brackets so it's clearly shown as one group. And yeah, that's the formula there. And another important note for doing integration by parts is the function you choose to be your f of x or your g of x is really important because the right hand side of the formula completely, like the way you handle f of x and g of x in the right hand side is very different. So you want to make sure to have your work be as easy as possible. So the rule of thumb that is usually used is this rule called ILATE. You may have heard of that. So it's basically a nice, easy way to remember the ordering of different kinds of functions. So this would so I would stand for inverse trigonometric functions, and L would stand for logarithmic functions. A would stand for algebraic functions. The T would stand for the regular trigonometric functions, and the E would stand for exponentials. So if we maybe we should go over a few, an example of each of them. So inverse trig functions would basically be like sine inverse of x or cosine inverse of x, stuff like that. Some folks call them arctangents, but I just call them inverse trigonometric functions. The next category of functions are logarithmic, so that would be a regular log of x and maybe log of 2x and different variations of that. So it has a log is probably a logarithmic function. Algebraic functions are what we usually see. So those are like x squared, 2x, 5x plus 1, stuff like that. Trigonometric would be like the regular trig functions. So like sine of x, cosine of x, and tan of x, stuff like that. Exponentials would be like e of x and like e of 2x and other variations of e to the some function of x. And yeah, so why this ordering is important, I will go through a few examples, a couple of examples, and maybe that would make things clearer. Okay, so let's jump to our first example. Let's try to do the integral of x times sine x. So when you're doing this, so this looks exactly like integration by parts because you have two functions, x and sine x, which are being multiplied, and you have to do like the integral of the entire expression. So now the decision we have to make is, do we choose x as the f of x or g of x? And similarly for sine of x, should sine of x be like the f of x or g of x? So since in according to the ILATE rule, uh, algebraic functions would come before trig functions. So you typically want, so if you have an algebraic function and a trig function, you would typically want the algebraic function to be f of x and the trig function to be g of x. Why that's the case is because you in the right hand side of the formula you would integrate g of x and you would like take the derivative of f of x. So you want g of x to be as easily integratable as possible. So coming back to our example, we already have it in the right order since x, which is the algebraic functions, comes before sine of x. So we can pick x to be the f of x and sine of x to be g of x. So now that we have that on lockdown, we can go ahead and solve this thing. So how do I remember the formula? So it would be the first function times the integral of second function minus the integral of the derivative of first function times the integral of the second function, um, Mr. X there, sin x dx, dx. I'm gonna put that in brackets so to make sure they're together. So this little d of x is for the sine x is for this integral, and the outer d of x is for this integral. Okay, now that we applied the formula, we can go ahead and solve the rest of it. So x and the integral of sine x. So the derivative of cosine is negative sine. So the integral of sine would be negative cosine. So that's going to be negative cosine of x minus, and I'm going to keep that integral symbol there. D over d of x would just be 1. Integral of sine of x. So the derivative of cosine is negative sine. So the integral of sine would be negative cosine of x. And that's I just brought down the brackets from before to make sure we know like what we did there. D of x, that's that one. All right, so solving this further, negative x cosine of x, and that negative. So that's just the one. So 1 times negative cosine x would just be negative cosine x. And then we would have, oh yeah, right, we have to integrate that. Um, So minus integral of negative cosine of x dx. And I'm going to make a slight modification here. So these two negatives here, I'm just going to change it to a positive. So that's gonna stay as it is, and that's gonna be plus integral of cosine. So the derivative of sine is cosine, so the integral of cosine would just be sine. So that would just be sine of x. And since we're doing indefinite integrals, we have to add the plus c there. And yeah, that's the solution to integral of x times sine x. Let's work to another example. So the second example we have is integral e to the x times cosine of x dx. So first we need to make sure like the ordering is right. So because ILATE and stuff. So we have an exponential and we have a trigonometric function. Um, and it would be ideal to have the trigonometric function be before exponential. So if we have a trig function and an exponential function, we would probably want the trig function to be f of x and the exponential function to be g of x. So here we're actually gonna have to flip the order. So because if I write it this way, it like e of x, which is the exponential, would be f of x, and that would not be ideal. So the ideal way to write this according to the ILATE rule would be integral cosine of x times e to the x dx. Now that we have that out of the way, we can go ahead and apply the formula. So first function times integral of second function minus integral of derivative of the first function cosine of x uh, times integral of the second function and dx will be cosine of x and integral of e to the x is just e to the x minus derivative of cosine would be negative sine and integral of e to the x is just e to the x dx. Okay, so since we have two negatives here, I'm just going to change both of them to positive. And let me just write it down again. E to the x cosine of x plus integral sine of x e to the x dx. So this, if you notice, is another integration by parts because we're multiplying two different functions here. So we kind of just apply the same formula we had above. And ILATE rule again. So we have a trig function and an exponential function, and we would want the trig function to be before the exponential function, which is what we have here. So we can just go ahead and apply the formula. E to the x cosine of x plus, so this would be first function times integral of the second function minus integral of the derivative of sine would be, so I'm just gonna apply the derivative quickly. So we do the derivative of the first function, which is sine of x. That would be derivative of sine is cosine, yeah. So cosine of x, and then we do the integral of second function e to the x. So that's gonna be e to the x dx. So let me just copy the first part of the expression here. So that would be sine of x, e to the x is just going to be e to the x. Integral of e to the x, just e to the x. Minus, and that's going to be integral cosine of x, e to the x, dx. Okay, so if you notice that we are kind of going in a loop here because we have e to the x and we integrate that a few times and that kind of stay as it is, and the sine and the cosine keep switching, right? I mean, obviously the sign, the SIGN sign changes, like it changes from negative to positive, positive to negative, but we're kind of flipping back and forth between sine and cosine. So if you kind of notice that's happening, it may help to look at what you originally started with. So what we originally started with was integral of e to the x times cosine x dx. And that's kind of exactly what we have here. Integral of cosine x times e to the x dx. So like this and this is the exact same thing. So I'm gonna do a cheeky substitution here. So I'm gonna write this as I equals. So I is basically this entire thing. So like this entire thing, I'm gonna call that I. And if I call that I, what I can do here is I can replace this expression by I. Which expression? This one. I can replace this expression by I. So I can write that as minus I. And if I do that, then I can write the entire expression as I equals. So I is going to be here as well, right? Because since we had I equals, well, I can basically write I. So all of this is just I. That's I, that's I. We're basically solving I, right? And yeah, in the end, we would have plus e to the x sine x minus I. So if we have that, we can just solve for I. So what I'm gonna do is I'm gonna take that and bring that over here. So the negative I from here becomes, so that becomes 2I. So we move that there, that's gonna become plus I plus I would be 2I equals e to the x cosine of x plus e to the x sine of x. And yeah, that's it. We bring the 2 over to the other side, we would get I equals, I'm gonna factor out e to the x just because we can. And all that over 2. And that would be our final answer. And yeah, forgot, not quite a final answer, missed the plus c there. And yeah, that would be our final answer. All right, hope that was helpful, and I'll see you all next time. Cheers.